King Air 90 Mike Lima.
90 Mike Lima, actual.
Yes, sir. We're coming out of Jet Center here and tagged in, standby clearance to clear to Nashville via direct Snowbird, direct Volunteer.
Respect, correct.
I've got a tunnel here now.
Terrain picture, the synthetic display is just terrific. I find myself just forgetting that that's not the real world that I'm looking at. Okay, flare cues coming up. 50, 40, 30, 20, 10.
Synthetic vision is one of the most exciting potential new advances for aviation in a long, long time. It's basically trying to bring a out-the-window view from the cockpit and represent a clear, sunny day, no matter what the outside conditions, either at night or in poor weather conditions. The number one safety issue, the number one fatality around the world are both rooted in the same problem, and that's when you can't see out the window of the aircraft, either at night or in poor visibility conditions, accidents happen. These mistakes happen. And so for the traveling public, if we are successful, for the commercial airline community, 30% of all fatal accidents would basically be eliminated. And that's the attractiveness of this whole technology. Safety benefits as well as operational benefits which result from the crew having a clear out-the-window type of view, even in low visibility conditions. As folks well know, when they go to the airport and it's foggy or it's stormy or it's rainy, there are very often flight delays. And the whole system slows down when the visibility conditions go down. Synthetic vision types of technologies on board the aircraft, again, will make the visibility conditions be clear day no matter what else is happening. And so the operational capability or operational limitations that happen when the weather goes down will be avoided.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Release.
Sorry about that.
Three. We
Okay,
have
turn
three.
them on. Okay.
Okay.
Okay. Turn them on.
All right. Power to desk on.
We test a lot of different types of structural designs. In an aircraft, there are several things that can help you in a crash. Some of those start at the landing gear, if it's down and in the right configuration when you crash into a surface. That's where we start. Some of that also incorporates the subfloor, and that's the area under the seats, where you have crushable zones or areas where you can put structures to take energy out, kind of like the bumper on your car crushes in a longitudinal crash. What we're trying to do is give companies and give the aircraft designers information on how they can better design their new aircraft to make them more crash-worthy and safer for occupants to travel in if they are in a crash. We build on what we have learned already. Sometimes it's the small tests in the lab, the building up of small structures that we do, that we test in a lab, and we iterate and iterate until we get something that we think is going to work. Then we put it in the real vehicle and we think it's going to work, and most times we have successes there. But when you don't, then you go back and you look at, okay, how can we improve this?
Selects, when it's plus, does that mean it's
You can zoom in and out. So it'll zoom on the location that you put it on.
Oh, okay, so if I...
They asked to fly from Dallas to Charleston, and let me put up some airports there, Dallas to Charleston. I'll zoom in on this a little bit, and you can see that between Dallas and Charleston, there's some weather.
operate in INS and radio, and the FAA will not let us fly it in GPS. It has because
Okay, I'm going to give you yours back. You're in INS now, right?
RDU, for instance, is Raleigh-Durham. ORF is Norfolk, near NASA Langley, where this system was developed. I'll put this back into history, and you can get an idea of how the thunderstorms are moving. Looks like they're sliding up this way a little bit.
What we're doing is we're looking at more than just a implementation of current generation weather in the flight deck. We're looking at ground networks. We're looking at how the data gets to the flight deck, not just in the sample, but the best data links for wherever you are in the world under the conditions you're in. So it's a worldwide implementation of putting better weather information in the flight deck. Also, what to do with that weather information when you're in a flight deck. You can build tools that can help him to where, for example, if the weather does go sour along the route, it's possible to build a tool to put up an alarm for him. So he doesn't have to monitor it anymore. He doesn't have to watch the graphics anymore. Also, you can build decision support tools. So, for example, instead of having to go into a regular complicated, what we call flight management computer or FMC and build new routes, you can have decision support tools that will actually pick out suggested routes to the pilot.
So the results of this study were that they actually saved 5% in time and fuel when they used this system. That rather than clip the thunderstorms, they were able to completely miss them twice as often. And when they did miss them, they tripled that miss distance. So you have a payback in airline passenger comfort, in safety because you're completely avoiding adverse weather, and also in fuel, which translates to dollars for the airline, and ultimately translates to lower ticket prices for the air traveler.
Okay, number one, I got clear, fuel, cap is on, vent door is open, all cooler door is open. Number one, turn it. All pressure good, 9 and above. Primary lights out. And stabilize, stabilize good. No,
tilt a little bit just to see that storm out there, right 1 to 2 o'clock.
Okay, so you want to get the radio up?
Oh, what was that? What was that? Yeah. There's another one popping up.
Yeah,
oh, yeah.
Taking us right through there. Oh, yeah, okay. Not sure what we're doing. You're going to
miles, link clear 6485.
15,000, 9245.
Oh, I see.
Break the 645 contact.
Yeah, this is our dot.
Okay. The heading.
Want to go the heading?
I did that once, yeah.
Convair, this is Chill.
Go ahead. Hi.
Do you see clouds ahead of you?
In it.
Well, we're in it.
We are seeing turbulence now. Yeah, so you can see it here going up or down.
Yeah. There's actually something there. Right.
What degree you got to set doing the landing?
But there's the
On an apron at Orlando International Airport, this specially equipped 737, a flying laboratory, goes through final checkout.
They're
A
about
nearby Doppler weather radar
15
station
kilometers
detects
north of the
thunderstorms in the area. Bad news for most air crews, but a great day to fly for a team of researchers from NASA Langley in Virginia. Their mission, evaluate systems that would warn pilots about approaching wind shear, strong, potentially hazardous currents of air that can accompany storms. The best way to do it? Fly right through them.
Contact Orlando on 119.4.
Once airborne, Mike Phillips and Dick Yenny
pass,
up front
you ready to take it in the back?
737's controls over to fellow NASA pilot Bruce
right.
flies the plane
Coming back
in the
around.
NASA research cockpit.
LiDAR looks good.
Guided by
Well, it
displays
did
from
look
weather
black in
radar
here.
on the
You said it was
ground
0.2.
and a variety of onboard
I believe you.
sensors.
Okay,
They
we
seek
got a radar
out
alert
and
of
fly
116,
through
2 miles
areas
dead
where a
ahead.
particularly
Going straight
threatening
down,
type
we're
of wind shear
900
called
feet, 2 miles, you got the
microbursts are likely to occur.
50.
Microbursts are powerful localized downdrafts that can literally knock an unsuspecting plane out of the sky during an approach or landing.
Yeah, we got some turbulence now. We're about 3 miles short.
Mike Lewis is NASA's Wind Shear Program Deputy Manager.
Between 1975 and 85, fully 50% of the aircraft fatalities were either directly or partially caused by this wind shear phenomenon.
The FAA has mandated that all airliners be equipped with some kind of wind shear advance warning system by 1995. The joint NASA-FAA effort in Orlando marks the culmination of years of study aimed at evaluating candidate technologies. A microwave radar housed in the 737's nose, a Doppler LiDAR under its forward cargo bay, and a side-mounted infrared device. Though each works differently, all three are designed to detect wind shear out ahead of an aircraft. Only by flying through storm cells where microbursts are present can researchers truly test the reliability of the sensors.
0.16 F-factor. Okay, say reflectivity, Lincoln.
To ensure safety, Mike Lewis evaluates information on the displays and guides the crew away from areas with hail, ground obstructions,
235 on the
or
ground speed,
dangerously
215 on
strong
the air.
winds.
Okay, sure.
Mike Phillips and Dick Yenny also make recommendations based on what they're seeing
we got a
up
big
front
airspeed increase already.
to fly the plane through the storms.
Heavy rain.
Altitudes above 750 feet and conservative airspeeds are maintained throughout. The task now is to analyze all the information gathered and make it available to the airlines. Program Manager Roland Bowles.
We think an ounce of prevention is worth a pound of cure. This program is directed at technology that will provide advance warning with ample time for pilots to avoid the affected area or escape from the encounter.
Once in place, detectors like those being tested in the NASA FAA program should greatly enhance the safety of air travel, according to veteran pilot Dick Yenny.
With this warning of 30 to 40 seconds, my goodness, there should be no reason whatsoever for a wind shear accident or even an incident.
I've got a tunnel here now.
Terrain picture, the synthetic display is just terrific. I find myself just forgetting that that's not the real world that I'm looking at. Okay, flare cues coming up. 50, 40, 30, 20, 10.
King Air 90 Mike Lima.
Mike Lima,
Yes, sir. We're coming out of Jet Center here and taxi in to stand by clearance to
Snowbird, direct volunteer.